Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Akmal bin Azman and my pair is Muhammad Fahmi bin Muhammad Nur. Today we are going to present about Chapter 5, Lab 5, Configure and Verify Path Control using PBR. So this lab consists of 7 steps and I will demonstrate step 1 to step 4 and Fahmi will do step 5 to step 7. So basically step 1 and step 3 is just a basic configuration for EIGRP and loopbacks and assign addresses. So I can show you from show run command. So for router 1, I've configured interface loopback 1, interface loopback 1, serial 10, serial 11. Okay, that's all. And the EIGRP for router 1. Okay, so for router 2, interface loopback 2, serial 10, serial 11, and the EIGRP for router 2. For router 3, loopback 3, serial 10, serial 11, serial 12, and the EIGRP for router 3. And lastly router 4, interface loopback 4, loopback 5, serial 10, and the EIGRP for router 4. So that's all for the basic configuration. To verify the configuration, we can show IP interface brief, show protocols, and show interfaces. The 3. So it shows here the protocol, the IP address is up, and this is the IP address for each of the interface that I have configured. And this is the protocols for R3. And this is the description for each of the interface that I have configured for router 3. So for router 1, same as the router 3. So this is the description for each of the interface in router 1 and protocol for router 1. And same goes to router 2 and router 4. Next, step 4, verify EIGRP connectivity. So these commands will show the neighbor for each of the router. For router 1, this is the router 3 and this is router 2. So these two router are router 1 neighbor for EIGRP. Okay, router 2, this is the router 3 and this is router 1. For router 3, this is router 2 router 1 and router 4. And lastly for router 4, this is the interface for router 3. So these are all the neighbors for each of the routers. Did you receive the output you expected? Yes. So next, test the connectivity from R1. Okay, all the pings are successful from R1 to all these addresses. It means that all the configuration that I've made is correct. So that's all from me for step 1 to step 4. Thank you.
Verify the current path. Before I configure PBR, I will verify the routing table on R1. So on R1, I use the show IP route command to notice the net hop IP address for all networks discovered by EIGRP. So the command is show IP route begin gateway. So the output here, the output that I get is same here for the IP route. So next on R4, use the trace route command to the R1 LAN address and source the ICMP packet from R4 LAN A and LAN B. Okay, I use the command here, trace route IP address 192.168.1.1, source 192.168.4.1, and I also do command trace out 192.168.1.1, source 192.168.4.129. So here is what I do on my lab. This is two of the trace out command that I already use here. So the output is same. So next, question: why are the R4 interfaces not using the R3 to R1 path? It is because the serial interfaces between routers R1 and router R3 have been configured with a lower bandwidth of 64 kilobyte per second, giving it a higher metric. All other serial interfaces are using the bandwidth setting of 128 kilobyte per second. R3 chooses to send all packet to R2 because of its lower metric. Next, on router 3, I use the show IP route command again, and note that the preferred route from R3 to R1 LAN 192.168.1.0/24 is via R2 using the R3 exit interfaces S1/1 on this I use on Gen S. So here is the command show IP route begin gateway. So here is where I configure the command until here. Okay, so I get the same output as in this lab. So next, on R3, I use the show interface serial 1/0 and show interface as 1/1. So here is the command. I also show interfaces as 1/0. So here is the command that I already configure. So here is the output that show in this terminal of R3. So we will highlight that the bandwidth is 64 kilobit per second. Okay. Next, show interface as 1/0 include BW bandwidth. So and also I use show interface as 1/1 include BW. So here is the command that I already configure for the first interface S1/0 and S1/1. So we can see that for the interface S1/0, the bandwidth is 64 bit per second, and for the interface S1/1, the bandwidth is 1 to 8 kilobit per second. So next, confirm that R3 has a valid route to reach R1 from its serial 1/0 interface using the show IP AJP topology 192.168.1.0 command. Okay, here on R3 also I configure command show IP AJP topology 192.168.1.0. So here is the command that I already configure. So in the result, the output is so you can see minimum bandwidth is 1 to 8 kilobit, and so the composite metric is same as the lab here. And next here is the composite metric, and the minimum bandwidth is 64 kilobit, so also same. Okay, as indicate, R4 has two routes to reach 192.168.1.0. However, the metric for the route to R1 172.168.1.13.1 is much higher than the metric of route to R2, making the route through R2 the successor route. Step 6. Configure PBR to provide path control. First, on router 3, I already create a standard access list called PBR SEL to identify the R4 LAN B network. So the command that I use is IP access dash list standard PBR dash SEL. Then in the access list, I configure command remark SEL meshes R4 LAN B traffic. Then permit IP address 192.168.4.128 0.0.0.127, then exit. So next, I create a route map called R3 to R1 that matches a PBR ACL and sets the next hop interface to the R1 as 1/1 interface. So the command that I use is route dash map R3 dash to dash R1 permit. Okay, in the route map, I use command description rm to forward LAN B traffic to R1. Next, mesh IP address PBR ACL. Then set IP next dash hop 172.16.13.1. Okay, then I apply the R3 to R1 route map to the serial interface on R3 that receive the traffic from R4. I use the IP policy route map command on interface S1/3. So the command is interface S 1/3. In the interface, I use command IP policy route dash map R3 dash to dash R1 and command N. So on R3, to display the policy and matches, I use the show route map command. So here is the command to display the policy. Okay, in the policy, the output that I get, same as the lab. Step 7, test the policy. Now I am ready to test the policy configured on R3. I will enable the debug IP policy command on R3 so that I can observe the policy decision making in action. To help filter the traffic, first I create a standard ACL that identifies all traffic from the R4 lanes. So on the R3 I already create a standard ACL which identify all of the R4 lanes. So the command is access list 1 permit 1 IP address 192.168.4.0 0.0.0.255, then exit. So to enable PBR debugging only for traffic that matches the R4 lanes, I use command debug IP policy ? Then I choose debug IP policy 1, which is access list. Okay, so here is the command that I already use here for the IP policy ? In the IP policy 1. Okay, same. Next, to test the policy from R4 with the traceroute command, I use R4 LAN A as the source network. So at router 4, I run command traceroute 192.168.1.1 source 192.168.4.1. So okay, here is the command and the output. Then to notice the path taken for the packet source from R4 LAN A is still going through R3 to R2 to R1. Okay, as the trace route was being executed, router R3 should be generating the following debug output. So we check on the R3. Okay, this is the output that has been generated on the R3. So next question, why is the traceroute traffic not using the R3 to R1 path as specified in the R3 to R1 policy? It does not take the PBR specified path because LAN A does not meet the criteria specified in the PBR ACL access list. Okay, to test the policy from R4 with the traceroute command, I use R4 LAN B as the source network. So I will do the same command again with but using R4 LAN B as the source network. So on the R4, I already run the command traceroute 192.168.1.1 source 192.168.4.129, and here is also the output. So the debug output on R3 also confirm that the traffic meets the criteria of the R3 to R1 policy. So we check on the R3, then here is being generated on the R3 too. Okay, next on R3, display the policy and matches using the show route map command. So on the R3, I configure command show route map. So here's the command. So and I have to highlight this, the policy meshes 12 packets, 384 bytes. Okay, same as the lab. Okay, that's all from me and my partner Ahmad Akmal. Thank you.